In this video, we're going to take a look at a subnetting problem that involves more than just Class C. So in this particular subnetting problem, we're looking for the first valid host on the subnetwork that the node 10.28.64.110 slash 255.255.240.0 belongs to. And the first thing we might notice is this looks like a Class A address, which is great. We can work with that. And the subnet mask looks like the divide is going to end up being in that third octet. So it almost kind of looks like a Class B, even though it is really a Class A. The problem is not that much different than what we've already seen. And in fact, what we do first is we just need to lay out this subnet mask. We need to dissect that so that we can see which part is the networks, which part is the subnets, and which part is the hosts. So that's what I'm going to do first. I'm going to take this subnet mask and I'm going to turn it into binary. So we start out with the first octet, which is all ones, 255, and the second one is all ones, also 255. And then this 240 in binary is actually 11110000. And you can convert that from decimal to binary using the methods that we've used before. The chart that you add 128, 64, 32, and 16 to get that 240. And then that last octet is all zeros. And what I like to do here is I like to kind of chop this up into the different parts of this subnet mask. So we know we're a Class A address because it starts with a 10, and anything 127 and below is going to be a Class A address. So Class A always divides after the first octet. So I draw my great divide there, and I'm dividing classfully. And then I draw my other line between the ones and the zeros. And this is the subdivide, or the area where we are looking between the subnets and the hosts. So we have three parts here. We have the networks, and that is what a Class A address would tell us we have available. We have the subnets, and we have the hosts. And if this subnet mask was 255.0.0.0, we would just have networks and hosts. But we can tell by this subnet mask and this Class A IP address that we are working with subnets and hosts here in this type of format. So this gives us an idea of how large this network is. And in fact, we can count how large this network is and how many subnets we have available to us. And I'll do that a little bit later. But the first thing I want to do now is I want to start to determine the answer. What is the first valid host on this network? On 10.28.64.110. Now this IP address is somewhere in this very large network. And we need to determine where the beginning is and where the end is, the first and last usable host. And we can determine all of that with one method. So that is what we're going to do here. And the first thing we need to do is we need to determine what we need to convert from the IP address into binary. Now if you really wanted to, you could convert all of it. But just a little bit of a shortcut, nothing is going to change in this first octet. The first usable host, the last usable host, all of it, the answer will be 10 in the first octet. And that's easy to tell because I can see that these are all ones. Anytime you have all ones in your subnet mask, that area of the IP address is not going to change in your answer. It's going to be the same from the smallest to the largest address. Same thing is going to apply here in this second octet. The second octet is going to be 28. It's not going to change. So I can just write these in here because I know they're not going to change and they're locked in for me. Now the one that gets a little strange is this third octet, and I need to be a little bit more careful with that one. And I need to take this 64 and place it in there so that I can see exactly how this is going to look, where it starts and where it ends. Now to convert 64 into binary, I'm using these 8 bits to do so. And 64 in binary is 01000000. This one happened to be an easy one because I know that this 7th from the right is worth 64, and I'm able to place that in there. If you need to convert 64 or whatever your number is to binary through another method, please do so, but make sure you lay it out completely in this octet. Okay? It's one of the few times we actually are using the octets here. A lot of times we're using just these lines. All right. And now that I have my IP address listed here, I can draw my N1LB chart. And this chart allows me to see the network ID, the first usable, the last usable, and the broadcast address. I'm also going to just draw a line here down the side just so that this 1 doesn't become part of my binary here, and that sometimes can throw off some of my numbers. Now, one thing we know here is that the subnet portion is never going to change. The definition of the network from the first host to the last host is never going to change. So anything with these 1s here, I can just carry on down. So I'm going to take this 0100 part, and I'm going to put this in here all the way down, 0100, 0100. Because no matter what host I choose in that network, it has to be within this network. It's kind of like bookends. It defines where the network starts and where the network ends, and you can never go outside of that boundary. Now, the next part we need to know is, what do we do with this host portion? What do we do over here? Now, you'll notice I didn't convert the rest of this host portion over. I didn't convert the 110 over. And you'll notice it's all zeros there. And that means it is going to be completely different. It doesn't need to be converted because that 110 is somewhere in a sea of IP addresses here. There's just tons of addresses. So I don't need to know specifically about this particular 110 in that 4th octet, because it's just going to be overwritten by my definitions of the network ID, first host, last host, and broadcast. So this is fairly irrelevant in this particular problem. The one that's important to convert is the one with the subdivide in it. That line there tells you where you need to convert from your IP address over into binary.